Okay, Algebra 1, this is chapter 1.8. We're going to actually interpret graphs today of functions. Basically, we're going to look at graphs, we're going to dissect them, and talk about the different parts of them and what they do. And then, that's all we're going to do today. So there's only basically 3 slides with 2 examples at the end, which is the 3rd slide. So this one is pretty straightforward. We just got a couple things that we want to talk about. What does it mean to be an intercept? This would break down to a y-intercept, an x-intercept. But what's an intercept? What does it mean to intercept? Intersection between 2 things, where 2 things cross, right? Two things cross. So what 2 things are crossing? Well, if we're talking about a y-intercept, it's a very specific intercept. It's where your function crosses or touches the y-axis. So it doesn't necessarily actually have to cross it, actually. So maybe when we cross or touch, a y-intercept for a function is where it touches or crosses the y-axis, and vice versa. When we talk about an x-intercept, it's where the function crosses / touches x-axis. So, if we wanted to, we could draw just a really quick graph down here, where these are my x and y axes, yes? And if I just drew a graph, I'll change colors here for us. If I drew a graph and went like this. This has 3 intercepts. We have a y-intercept here. Can everybody agree with that? So that's our y-intercept. And maybe I'm just going to put y-intercept for now. That could be a parabola, yes. I just drew something up there. If you want, put little arrows on it. Now we say yes, that's a parabola. We also would say that this point and this point, these 2 out here, are called the x-intercept. So those are x-intercepts. Now, in our particular problems, you're going to have to look at the graph. You're going to have to actually state what they are. Now, guys, x and y intercepts are points. And so I very well could go back and draw tick marks on here. Okay? If I make tick marks, now you have a scale. Can you tell me these x and y intercepts? So let's talk about the y-intercept. What is the y-intercept? Who's got it? 0, 3. I like 0, 3 better than just 3 because it is a point. And points are made up of x, comma, y. I am not going left or right. I'm just going up 3. So therefore it's 0, 3. What about the x-intercept on the left?
0, negative 4. 3, 0.
Switch. Switch them.
Negative 4, 0.
-4, 0.
What? Oh, x-intercept. Okay.
Going for the x-intercept. It's -4 to the left first, and then going up and down nowhere.
3, 0.
And then the one on the right is 3, 0. Yes, there's an x-intercept on both sides. There actually is enough information right there if you guys wanted to draw or figure out the equation, of that parabola. That's something for next year, I do believe. We also, guys, have something called a line of symmetry. What does it mean to have symmetry?
Have depth.
Fritz. Yes, when both sides are equal. So the line of symmetry would be the line that cuts it in half. So a line of symmetry, we'll say, cuts a graph in half. Yeah, we'll say, if you want to say line that cuts graph in half. Now, we in this class are only going to deal with stating if it has a line of symmetry of the x-axis and the y-axis. So that means, is it symmetric about the x-axis, or the y-axis, sorry, that's y. The y-axis, or is it symmetric about the x-axis? Well, first of all, looking at the x-axis, is it the same on both sides? No. So this would not be symmetric about the x-axis. Is it symmetric about the y-axis? No. Why is this actually a no? It looks like it could be yes, but why is it no? How do we know? Real. Say it again? There isn't on the bottom. Remember, we're talking about the y-axis, so we're going actually left to right. There is a line of symmetry to this. The line of symmetry, guys, is over here someplace. Why? How do I know this? Look at your x-intercepts. Yeah, the x-intercepts, guys. The one on the right's only 3 away from here, and this one over here on the left is 4 away. To be symmetric, the middle is the line of symmetry. So what is 4 plus 3? What's negative 4 plus 3? It's negative 1. Divide by 2? Be a negative 1/2. So the line of symmetry is x equals negative 1/2. Remember, line of symmetry cuts a graph in half. This does have a line of symmetry. It just does not happen to be the x or the y-axis. Now, a lot of information here. I just took this straight from the book. The first box on the top left talks about where is the graph positive and where is it negative. The graph is considered positive where it's above the x-axis. Where are the values of y positive? Notice that this graph looks like an upside down N. There are times where it's in blue, it's positive, and parts where it's red, it's negative. So negative is where the graph is below the x-axis.
Where is the upside down? Yeah, but why?
So that's a positive and negative parts of the graph. The next one is increasing and decreasing. Now, we always look at our graphs, just like we do our equations, left to right. So I start over here and I work my way this way. If I am starting at the left-hand side and I am falling, that part of the graph is called decreasing. Notice that decreasing goes further than it being a positive graph. It goes all the way to the point where it hits the ground, right? The bottom part of that curve. And then it starts going back up, or we say increasing. And then all of a sudden it hits the top of the hill like the roller coaster and falls down for ever. So, notice that it's increasing forever on the very far left. Increasing over here to the point it gets to the bottom of the hill, then it increases and then it decreases again. There could be multiple changes of positives and negatives and increases and decreases. We then talk about those changes, those hills, okay? And in those hills, guys, if I asked you on this particular graph here, is there a maximum or is there a minimum? You would have to say no. There's no maximum because you're like, oh, look, This is the biggest number. No, it's not. This number right here is bigger. No, wait. There's one that's right here is bigger. And then there's one over here that's bigger. And then it just keeps on going forever. So, guys, the graph goes to positive infinity when your x values go to from negative infinity. And vice versa, there's no negative, or minimum, sorry, because it goes down to negative infinity forever. So we can't necessarily say that there's a maximum or a minimum for this problem. Sometimes there are maxes and mins. I'll revert back here. This particular problem has a maximum. The maximum happens right here. It actually is not at 0.3. It would be slightly above 0.3. We're not going to get into that. But you could see that there would be a maximum. There's no minimum because it goes down forever. So when you're looking at this, all you have to state is, hey, right there is a relative minimum. So what we're going to do is we're going to lob off the going to infinity parts and only talk about the changes that happen within the graph. And of all of the changes, sometimes there's multiple changes. Look for the lowest one and look for the highest one. The lowest one is your relative minimum, and the tallest one is your relative maximum. Okay? And the last one is called end behavior. End behavior is what is going on at the ends. Now, on the very bottom there, I see that it's also very small. I just basically want you to fill in the question marks. As x approaches, that's why we have little arrows here. Little arrow right there. As x approaches infinity, that's a sideways 8. Y approaches where? Think about this. Let's track x. X is right here. This is this part right here. As x goes to positive infinity, which is going this way, where is y going? It's going down. Will it ever stop? So therefore, it's going to... So as x... I'm going to change that color. I'll change it back to red so you can see it. So I state, as x approaches infinity, y is approaching negative infinity. It's a negative sign in front there, right? I then go back and say, as x approaches negative infinity, where's y going? So now x goes this way. Where's y going? It's going to positive infinity. So I write positive infinity. And that's end behavior, guys. I want to see both of those for your graph. That's how you state it. It's basically those little words and those little bubbles. I'm putting it into a statement instead. Okay? What I did here, guys, is I basically took the directions straight out of the book. And it says identify the function graphed as linear or nonlinear. Easy enough, right? Linear means a line. Nonlinear is anything but a line. And then it says estimate and interpret the intercepts. That's number 1. Any symmetry. Number 2. Where the function is positive, negative. That's 3. Increasing, decreasing. 4. The x coordinate of any relative max or mins. 5. And end behavior 6. I think there's 6, maybe if I missed one, 7 things that we have to talk about here. So just start listing them. Okay. Number 1, linear, nonlinear. It's linear. It looks like a line. Okay. Is everybody okay with that? Yeah. Okay. Estimate and interpret intercepts. Any intercepts? is across the x or y axes, or touch them.
Y.
Okay, we have a y-intercept. Where?
0 and 241.
Okay, is everybody okay with that? 0, 241. That's a 241. Because it looks like it's approaching, so definitely above 240, yes? Maybe that might be a good option. Maybe it should be maybe about 250. I don't know. Again, we're interpreting, right? We're estimating. Do we have an x-intercept?
Yes.
X-intercept would be what?
0.
It's not 0. It's 10, 0. I think that one's a little easier to get the scale of and figure out, right? Okay. Now, is there any line of symmetry?
No.
Now, think of this. Is the x-axis, is it symmetric about this y-axis? Is it flipped onto the other side to be the same? No. How about the x-axis? The answer is no. So we know it's not symmetric about the x or y. But think of this. Could I actually create a line that would make it a mirror image on the other side? I think I could. Actually, if you think about it, it's a line. Does it matter where I split a line?
No.
There can always be another side of the line that looks exactly the same. Like any of these options, I'll take them out after. Could that split it?
Yes.
It just has to be perpendicular. You guys know that word? To meet at a right angle, to be completely opposite way, right? That would create a graph that goes on forever this way, and a graph that goes on forever that way, and it would be a mirror image of each other. Or it could be there, it could be there, or it could be there. Would you guys agree with this? So, take those out. So there are an infinite amount of ways to say that this does have symmetry. But what we're really talking about, I think, for this particular graph is x or y axis. Where is the function positive? So, I might want to list that, positive.
Everywhere.
I don't know if I could say that.
Or the negative.
Well,
Oh,
there's an arrow, guys.
240 maybe. Oh, yeah.
There's an arrow. I'm assuming this graph goes down for forever.
So, X,
So where would the graph be positive?
Y, X,
At x what?
X. At 10, 0, right?
At 10, 0. At 10, 0, it actually is the changeover spot.
Yeah, that's
You guys agree that right here, if something's going to happen, it's going to change.
Yep.
It goes from being positive to negative. So that means, what if x was less than 10? For any value of x less than 10, this graph stays positive because I'm talking about this dotted line right there, right? That wall. If I stay to the left of that wall, I'm positive. To the right of it, negative, which makes it x has to be greater than 10. You guys agree with this? How come I don't say equal to in any of these? Well, I guess the question is 0 positive or negative?
Neither.
Neither.
It might be considered a positive number, but we can just say, hey, at 10, something's going to happen. It's going to switch from one side to the other. So, when it's bigger than 10, the value of this graph is going down here, so it's negative. Where is the graph increasing?
Nowhere.
It's not. It's not increasing, correct. There is no increasing parts on this graph at all. Decreasing? How about always? It's always decreasing. Yeah, it's going downhill. You're gaining speed the whole entire time. Next, go up there and say x coordinates of any relative extremes. Relative max or min. Any max or mins?
No.
No, none. So it's none. And now it goes to end behavior. As x approaches positive infinity, as x approaches negative infinity, y is approaching where? As I let x go to positive infinity. So here we go. X is going larger, 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 larger. Y is?
It's growing as well.
It's growing, but downhill, which means it's going to negative infinity. And if I went the other way and said, hey, I'm going to let x get very, 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 very small, y happens to be climbing, climbing, climbing to
Positive.
positive infinity. Your homework is worksheet 1.8. Have a great day.